All right, good morning, everyone. So today, I'll be honest with you, is a very short class for you guys, but we are covering some very, very key concepts that I need you to understand. Answer the questions that I ask you, submit it back so that we can all be on the same page. The reason is because this will come up time and time again as we go through chemistry. It's kind of like when you learn about observations or the metric conversions, right? It keeps reappearing throughout the unit. So the concepts we're going to talk about today are physical versus chemical changes in substances. Okay, so yesterday or the past couple of days, we've been learning about substances and how it's all the stuff around you. Well, that stuff can interact with other stuff, right? Either in a physical way or a chemical way, and then change as a result. Now, I'm not sure if you guys talked about this in elementary school, but regardless, physical change is simply a change from one state, solid, liquid, gas, to another without a change in chemical composition. So it's still the same thing. This is like ice melting to water, evaporating to water vapor, right? So, and that is what the brain pop is going to be all about, is physical change when something goes from solid to liquid to gas. And we'll talk about this later on as well, okay? But the key here is that it doesn't change its chemical composition. It's still the same thing, right? Nothing new is formed. And if you want it to, the substance could be changed back to the state it was. So if you think of ice, if it melts to water, you could turn it to ice again. You just need to freeze it, right? So here's some examples, right? Glass breaking is a great example, okay? Is it still glass? Yes. Did it change how it looks? Yeah, right? So it's a physical change. Other things are melting, freezing, evaporating, tearing something up into pieces, or something being what's called malleable, meaning like you can bang it with a hammer and it changes its form, but it's still the same thing, right? So that is physical change. The next kind of change is chemical change. And this is a process during which the particles of a starting substance, reactants, rearrange themselves to form new substances called products. We'll spend a whole lesson on this, so this is just a little preview. But the key here is something new is formed that was not there before. That is a chemical change. The substance can also not be changed back to what it was previously. It's impossible, right? It's changed itself completely. It's rearranged it at a molecular level. So what are some examples of that? Explosions, right? Explosions are a great example. Now, an explosion in and of itself isn't the new thing created. Okay? In this example, right, a bunch of different elements are interacting here, and it releases a really, really fast combustion of something new. So fast that it creates heat, which compounds on itself, which causes an explosion. Okay? So what I need you to understand is the things I list here are not the new thing being created. Okay? Like a color change, the color is not the new thing being created, but something new was created that is that color. So for example, if you see this water mixed with something else and it turns to yellow, right, then that could be evidence that something has happened, right? So that's why I call it evidence of chemical change. It tells us that something new is formed. So color change can be an indicator. Fire, something catching fire, is an indicator. Anytime you light something on fire, you are making something new. When something explodes or combusts, like we said before, fizzing or bubbling, okay, and rusting and tarnishing. Now, the reason we're focusing on this is because in your lab coming up tomorrow, right, and students doing it yesterday found this out, when you add water to our mystery mixture, what happens, right? It bubbles, okay? So something new is actually being formed when you are putting water into your mystery mixture. We'll find out what that is later, okay? But that is evidence of a chemical change, okay? So just a short little presentation here. You're going to watch a brain pop. It's going to talk about the physical change side of things. Then you're going to complete a worksheet and hand that in, and you'll be done for the day, okay? So work hard, have fun, and I will see you tomorrow.